Hello, everybody. Welcome back. So we are going to be finding the domain algebraically, which means we don't have the aid of a graph unless we decide to create one on our own. This is much more difficult than finding the domain graphically. We're also going to find the range algebraically, but we'll say that for another day. So remember, the domain of a function or really any relation is just the set of all input values. So we're trying to describe a set. Here's our first example. F of x equals x squared plus 10x plus 16. You know that this is a parabola. Now think about what you know about parabolas. They look like the horseshoe, but they're continuous, which means you could draw a parabola without ever lifting your pencil. That means all the x values are contained for whatever curve that you draw. Furthermore, no matter what parabola you do draw, it's going to go up or it's going to go down, but it's going to go to the left forever and it's going to go to the right forever. So this is an example of, this is actually this parabola. If you can, this is factorable. We'll talk about that in a second. But even if you didn't know exactly what this looked like, you know that it's a parabola. So it goes to the left forever. It goes to the right forever. It doesn't jump over anything, no holes or anything. So the domain is simply all real numbers from negative infinity to infinity. Remember, you can write capital R. Well, that's an easy one. But g of x, not so much. The square root of this. How are you going to find this domain without the graph and without a calculator? Easier than you think. Let's first of all think about, let's go back to x squared plus 10x plus 16. We know that it's this parabola. And the only difference between g of x and f of x is that g just really takes the square root of this. So what does that mean to take the square root of f of x here? Remember, f of x is the output, it's the range. And the range on the graph represents all the y values. So here the y value is 0, here the y value is 0, here the y value is 5, here the y value is negative 5. I want to square root all of those y values. Well, starting off with an easy one, the square root of 0 is 0. So this graph is going to have the same zeros. The square root of any negative number, all these negative y values, if I take the square root of those, I'm going to get an imaginary number. And that cannot be graphed on a real plane. In fact, we're not really going to talk about imaginary numbers until May. So don't worry about imaginary numbers for now. When we're finding the domain, we almost always want to find the set that doesn't result in imaginary numbers. So back to this. We're taking the square root of this parabola, and this portion of the parabola are all negative range values. And taking the square root will result in an imaginary number. So we get to just ignore those. The x values that produce these won't be in the domain of this function. We just want the x values that produce y values that are positive or 0, so that I'm actually able to take the square root. Now, it's powerful to realize that you can actually imagine what this graph looks like just by knowing a little bit. Let me explain. X squared plus 10x plus 16 factors into x plus 8 times x plus 2. That means you know the zeros. The zeros are negative 8 and negative 2. And just graphing the parabola, having zeros at negative 8 and negative 2, and now apply the square root, it'll look something like this. Because this went back up here to the parabola, the square root of 4 will be 2. So what was originally 4 now becomes 2. The square root of 9 will become 3. So that's why it's kind of, the y values aren't increasing as much. Notice the square root of 0 is still 0. And the square root of 0 is 0. And also notice that all these y values, since they're negative, taking the square root doesn't produce a real number. That's why it's totally blank right here. Now, what is the domain of this? All x values that you see existing here. So anything to the left of negative 8 and to the right of negative 2. So here's our number line. Always handy to have this available. So I want all possible numbers that are greater than -2, but less than -8. So as you can see, it splits up my number line into 2 intervals. So your correct answer will have 2 intervals, from -infinity to -8, including -8, because you could take the square root of 0, and then from -2 to infinity. So the success, why we were successful here, this looks pretty nasty. This quadratic was factorable. And if you can factor it, you know exactly where the zeros are. And if you know where the zeros are, then you know what portion of the quadratic is greater than 0 and which portion is less than 0. And since you're taking the square root of that quadratic, you can only take the square root of numbers that are positive, so bigger than 0. Or you could take the square root of 0 as well, but you can't take the square root of a negative. We'll practice some more. Here's same concept, the square root of this quadratic. This quadratic is factorable. I don't care how you factor it, as long as you factor it successfully. This example is called the master product. You would multiply a and c, you get -21, and then find 2 numbers that multiply to -21 and add to 20, and those 2 numbers are -1 and 21. You factor by grouping, and you end up getting this, 3x minus 1 times x plus 7. So f of x is the square root of 3x minus 1 times x plus 7. That's a parabola. I know it's a parabola. I know it's facing up because the a value is positive, and the zeros are at 1/3 and -7. So imagine in your head a parabola that's shooting through -7 and through 1/3. What x values will produce positive y values in that situation? And if it helps, sketch a graph. That's totally legal. You're still doing it algebraically. If you sketch a graph to help you, that's totally fine. So I can draw a quick cross and then sketch a parabola. I know it's hitting the zeros, the x-intercept at -7 and 1/3. So I've got a positive x-intercept and a -1. So it looks something like that. And notice my y-intercept would have been -7, and there's my y-intercept. But if I take the square root of that, then remember, I can only take the square root of positives. I can't take the square root of these negatives. So I want my domain are the x values that produce these y values and these y values. So my domain is any x value less than -7. Uh, 4, 6, 8, so -7. So less than -7, or also greater than 1/3. So again, 2 intervals. And you include those endpoints. Whoops, that infinity should not have a bracket. So you're including -7 and you're including 1/3. Next example, love this one. Not a quadratic, so don't worry about factoring anymore. What's going on here? Well, you've got -3 divided by x plus 10. And when you're finding the domain, a lot of times it's easy to think, well, let's just assume any x value will work. I could plug in 5. Why not? -3 divided by 15. I could do that. I could plug in 100. -3 divided by 110. That's possible. But there's one number you can't plug in for x because it would result in division by 0. -10 is that number. -10 is absolutely out of this domain because -10 results in division by 0. Any other number is fine. -10 is a problem. So you can think of, here's the real number line, assume all numbers work, but then look at it again and think, and could I divide by 0 here? And yes, you can. -10 is the problem. So you would have a hole at -10. And that again separates the number line into two sections. The section to the left of -10 and the section to the right of -10. And there you have the interval, not including -10.